Like that it is there. So RNN is mainly for dealing about the sequence of data. Sequence of data like a sentence. I am handling neural networks and deep learning. That is the sentence I am giving. Okay. Suppose I have recorded my Alexa, or the Alexa is given a training that which teacher is dealing with the subject. Like that I have given a training to my Alexa. Okay. So then I am asking which subject Nanda madam is handling. That is the question asked to Alexa. It is going to answer Nanda madam is handling neural networks and deep learning. So it is a sequence of data where one word impacts on other word. Okay. When it knows Lata, the teacher name, only then it will be able to answer it as neural networks and deep learning. The sequence of data is getting processed. You are asking your Siri, what is the time now? So what is the question? Time. You are asking about the time. So it will read, it will understand, and it will respond accordingly. A sequence of data is getting processed. You are translating a language from English to Spanish. Okay. So the statement what you are giving in English needs to be converted in some other language. A sequence of the things has to be understood by the system, and then the conversion is taking place. Clear? Whenever we process a sequence of data, we go with recurrent neural networks. Why? What is the problem with the other networks? What is the problem with other multi-layer perceptron? There, the problem is it will not be able to remember the previous data. Means when you just recurrent a neural network, each node will be taking a different input, and that will be processed through the hidden layer and then output layer. Okay, due to which there is no dependency between the input. Whereas here, sequence of data you are giving, like which subject Lata madam is handling. This is the question, or this is the sentence I am giving it as an input. Okay, so the which alone is processed by set of things now, it is not going to help because the question is subject handled by so and so teacher. So it must know the teacher name and it must know the answer is Nndl. Okay, for that each word has to be continuously processed, like one after the other. It cannot be processed parallelly. Please remember, normally in other neural networks, parallelly it will be taken place process, whereas here one after the other process has to be taken place. So for that, a simple RNN model or recurrent neuron, we denote in this manner. I am giving here X as the input, which will be self loop, and then it will be producing, I can say it is yi cap or ya. Very simple recurrent neuron here. So we are giving here self loop, which means, so I am having which subject is subject. Okay, so first neuron will be dealing about this which. Okay, you have so many hidden layers. The first hidden layer will be processing this word. Okay, second hidden layer will be processing this. If you recollect the complete architecture of RNN, there will be so many blocks RNN cell. Each one will be taking one input, X1, X2, X3. Let us assume this is X1, this is X2, and this is X3. Okay, so X1 is fed to the first layer, which is getting processed. There is no support, but maybe you can have some initial value for the weight. With that it is processed. When you go to second layer, you are feeding this X2 as well as this is considered. Together only it is processed in the second layer. Since I process first word, once again I am feeding it to the same system, so that the second word is processed with the support of the first word. Then I move on to the third word. Third word process is taken place with the support of the previous output as well as the current input. This is how the process go on. Get it? Because one after the other the process will be taken place, but one impacts on the other. Whereas in other neural networks, each one will be done parallelly. So one input doesn't impact on other. There we will be giving a different features. Kind of like I want to recognize animal as whether it is a dog or fox or something like that, monkey, and I want to identify. So each neuron will be taking eyes as input, mouth as input, ears as input, face as input, head as input. Like that I am feeding the input to individual neuron. But here because all are independent, so that will go through various hidden layers. Only that feature alone is processed. Combinedly when it goes to the next layer, so this feature SR, no, if it is S, that also accumulated over there. Like that it goes on. But here to process the second itself, you require the first one because there is a dependency. This is a sequence of data. Whether RNN is used only for the sequence of data, it is not like that. Even for the timeline data. So suppose I want to see a stock forecasting or weather forecasting. If it is a machine learning, normally if it is a machine learning, this is how the past history says. So machine learning weather forecasting, I take a small window, based on that I do an analysis, I forecast for the next week or next few days. Whereas we go with the deep learning because we will be able to analyze deeply. That is the reason we say it is a deep learning where the entire history is analyzed and I will be able to forecast for the next 1 week. So at time T1 this was the case, at time T2 this was the case, T3. So depending upon the time it varies. So when between T3 and T4 this is the scenario, T4 and T5 this may be the scenario. Like at 10 o'clock this is the temperature, 11 o'clock it cannot be too drastic variation or a 20°C variation to possibility kadayadu. Okay, suppose from 10 o'clock to 1 o'clock if you see there will be a big variations. Whereas you are checking for half an hour, you are checking for 1 hour now, there won't be much variation in the temperature. So adhe madha stock forecasting inniki ipdi irukuna naளைக்கு suddenly it will not go down. If you just check even the gold price and all, so day by day it will reduce. Day by day it will be. That is the reason every day they will give an announcement. This much paise reduced or this much paise it is raised. Sudden suppose any disaster, any environmental changes taken place or any financial crisis taken place, only during that time there will be a drastic variation. Otherwise with the time it will gradually only either increase or decrease. So RNN is used mainly for processing sequence of data, processing timeline data, time step data. At time this, at time T2 this is the case, at time T3 this is the case. This is how it will go on. So normally text is converted as a vector. Text is converted as a vector for any process. Okay, so you may be knowing about bag of words and TF-IDF word into vector and all. So with that, when we are converting, the process will not be too accurate. That is the reason we go with RNN. So what you need to understand is RNN is also a artificial neural network where it is used to process a sequence of data. It is able to process the data which is a time bounded one. This much is enough as a definition. Fine. So various examples, your Google Translator it may be, or it may be a language translator, your natural language processing, or it may be text recognition, could be of anything. Okay. So this is the single recurrent neuron alone. So you see RNN architecture with a small example. I will just show you how it is getting processed. And normally there will be a 3 activation functions we will be using. So at input layer 1 and on the header layer another activation function. Finally at the end in the output layer normally we will be using softmax as a activation function. we are using is sigmoid. Sigmoid is good, but the thing is it ranges the value between 0 and 1. Between 0 and 1. Okay. So due to this we face some problem. Before that we will just complete the architecture part. Then I will come to the problem with RNN. I am going to take only a 4-layer RNN. Let us assume this is at T1, which will be producing output. There is no change in weight. You must remember there is no weight in the forward phase, whereas like weight updation will not be taken place in the forward propagation. Whereas in the backward propagation alone, we will be updating the weight. As always, here the gradient we will be using derivatives to update it. So in any simple neural network or any other model, input is multiplied with the weight and then add with the bias value, then apply activation function. You just recollect on the neural network, you pass the input into weight, okay, add bias value, apply activation function on each neuron. That is how any neuron functions. Whereas here, when we apply the activation, that is the final activation function. So here, my text is comprised of totally 4 words. Okay, so x11, x12, x13, x14. There are 4 words in my text, in my sentence. Okay, so there is, here 4. Same only is simulated here. Same thing only is given. My network, my model is having 4 neurons. All are 4 neurons or 4 hidden layers I am having. So x11, the first word is processed over there. Only first word is processed. x11 only I am passing with the same weight. So it is getting processed as always. X into w plus bias value is added and I apply activation function which is will be of sigmoid. Okay, so that is understood, so we don't represent here anyway. So that creates output which is named as the O1 and the weight also, because it is a package, it will be a package, it will be sent to the next. I have already said this as a state matrix. In the form of a matrix it will be produced where your output as well as weight will be there, which is given as an input over here to process second. So this is my sentence. So for the first step, at time t1, only I is processed over there. It is producing output and this output is taken. Second word what I am passing through this is like, and that is getting processed, that is generating here. Like that it goes on. Finally I get an output. On that I apply softmax function which will be producing the final output, which will be producing a different one. So as always there will be even a loss over here, y minus y cap. Y cap is the produced output, y will be the predicted output. So there may be a loss. Please see the difference. Loss, if it is too much deviated, obviously we need to once again process it, and at that time again we go back. We go back. Till now we have not updated the weight. We have not updated the weight on each stage. I have used same weight only. I have not updated any weight. But now when I go backward propagation, and that is where your BRNN comes. Bidirectional RNN. When my RNN is able to go back for process, see RNN itself is a feedback one. You process and that data is fed. The entire thing is only this one. I am first neuron will process first word, second neuron will process like the first layer will process the first word, second layer will process the second word, like that it goes on. Okay, it itself is a feedback loop only. That's why it is called recurrent neural network. With the forward propagation itself, it is a simple RNN. It is a simple RNN, but there may be a loss. To prevent or to reduce the loss, I may have to implement or I may have to even incorporate backward propagation. So when I go backward, the arrow will be like this because I am going to even incorporate backward propagation. So when I go for backward propagation, all the gradient descent will be there. Using the gradient descent or to optimize this loss, I have various methods. Okay, to optimize this loss, I go with the regularization. So to achieve regularization, I will be using gradient function. Formula will be same as earlier because what I am going to do now, I am going to update the weight. So how do I update the weight? W nu is equal to W old minus E. I use the symbol theta symbol. Yeah, eta Indian. It must be W old, but directly we don't write it. So derivative of loss by, this is what we have done for gradient descent. Okay. So this again we will be adopting even the chain rule because we don't stop only one way we will update and see the output. If it is okay, just leave it. Or sometimes you may have to update this weight. If that is the case, whatever you are updating over here, that will be propagated over there, and this will be combined here, and then you go forward. Okay, chain rule is applied. To update this particular thing, I may have to impact R because this W11 is impacted by this. O4 is impacted by O3 and O3 is impacted by O2. It is not a single output alone. So I may have to go backward and combine all those things and then do. When I do so, when I apply chain rule here, what will be the problem? There only I find two problems. One is the vanishing gradient. Okay. So mathematically, if you do that, we will be able to understand clearly. But I take a very simple value alone and then I will show you. Okay. So we are updating this. Suppose this is only a 4 steps. When I am taking the derivative, you get suppose this is something like 2.50, and my learning rate is something 1. And the derivative value what I am getting is something like 0.2. Okay, so what is the value I will be getting for W nu? It will be of 2.30. I will be getting value of 2.30. This is for the nth step. Okay, that value will be taken for here. When it comes over here, again the change could be of something like 2.28, very slight variation. When it goes the previous step, it will be something like 2.27. At certain point, both will be same. I cannot the procedure what I follow and I am using the derivative. That problem only is called vanishing gradient. So when I am not able to update the weight over here, how do I prevent the loss? I cannot avoid the loss, right? That's a problem. We call it as vanishing gradient. The gradient value is lost. It is vanished. It is ignored. So for 4 layers it is fine, but in the practical problems there will be n number of layers, maybe 100 or 200. When it goes to the 100th layer, which needs to tell me the output final answer of me, it will be a problem due to the vanishing gradient. Sure, okay, vanishing gradient, this kind of problem is created. Let me go with other way. Okay, so if we are going the other way method, suppose I am changing here the formula, I am making some changes over here. Okay, so due to which if I am taking and your sigmoid, here the very important thing is sigmoid will take the value between 0 and 1, and I am taking the derivative of last one, derivative value. So when I take derivation between 0 and 1, I will be getting value as only 0.25. 0.25, that is a very minimalized value, only that would be used everywhere. Okay, fine, sigmoid is creating this problem. Let me go with the ReLU. It is the activation function which uses for the non-linear function. So when I go with the ReLU, what happens? My weight updation will jump here and there due to this function. So when sigmoid alone was there, they found the problem of vanishing gradient and they stopped their work during 80s, 90s and all. And during 2014 time only they introduced this ReLU. The moment they introduced ReLU, they wanted to apply on it, and at that time what they found is this started jumping here and there so that they couldn't reach the global minima. Why we need to reach global minima? Because regularization. Okay, the regularization, you want to achieve the regularization, you want to avoid the overfitting, we need to go with this. Overfitting is always possible with the deep learning network because you are introducing lot of layers over there. If it is machine learning, there won't be any possibility for the overfitting because we can reduce the number of layers over there. But there it is a possibility of underfitting. When the number of layers are very less, it is possible for underfitting. When the number of layers are too many, then it will lead for the overfitting. And the overfitting or the regularize பண்றதுக்காக we are going with various techniques, right? So this may be jumping here and there so that I will not be able to reach the global minima. That problem is called exploding gradient. Exploding gradient. These two are the main problems with my RNN. Okay, so I know what is RNN, how the RNN works, and now what are all the problems with RNN. Okay, there are two very familiar functions I use, sigmoid and ReLU. That is where I introduce another function, tan. See, this tan function also, it is not so this thing. This is 0 to 1. This is 0 to 1. This tan h also limiting from 0 to 1 only. Okay, so there also I found this kind of problems, and that is where I introduce a variation on the RNN. Variation on RNN, which is nothing but LSTM. What is LSTM? Long short-term memory. So it will retain for long time, but the memory is only for short term, which means here there are two possibilities which I did not explain in the previous classes. I thought it's not much important for you. How exactly this is being implemented? There will be two kinds of memory. LSTM this LSTM is constructed by gates. It is constructed by gates. There are two gates over there. One is a forget gate. Other one is an input gate. Other one is an input gate. Okay. Yes. K7 is interested in doing social services. So he wants to participate on NSS based activities. Okay. the he, not she. I cannot give she. So this K7 only decides in the next statement whether it should be he or she. He or she. Suppose in between I am bringing another statement. Okay. So Muslim ma'am is in charge of NSS. She advises so and so. So after I brought this Muslim ma'am is in charge of NSS, there again I cannot use he. You are able to follow this example? K7 is interested in social services, so he joined in NSS and doing various NSS activities. So that is context, followed by there is another statement comes, Muslim are in charge of NSS. So she is advising the people to do so and so. Right? So now till I get a new input, Muslim, the next character, my gate should remember it must be he. Okay, the moment I brought Muslim over there, my forget gate will be disabling the he, and now onwards the input given is Muslim. So now onwards it has to remember she till I get the next character statement, that is male or female. Based on that only we will be giving the what do you say, that subject, the character, based on the character only she or it, whatever it needs to be used. So which one to remember, which one to be input, which one to be forgotten, that will be decided by these two gates. It will remember always. The moment you give another input, it will forget the previous one. Like that alternatively it will be functioning. That is how it will remember, because till that point only I see. Let us forget this example. So and so person, Ramu was staying in Andhra Pradesh for 10 years, so he is fluent in speaking Telugu. Okay, so instead of giving that Ramu was staying in Andhra Pradesh for 10 years and Sita was playing tennis. After that, so she speaks fluently or he speaks fluently. Again, this fluent, if that comes, it is connected to the previous one. Okay, the previous one. So that time it will be directed to that. This gate, current forget gate will be reopened. So it will remember that. Based on that, it will say fluent in Telugu. Or it is about the game. If that is the case, so that forget itself. So currently in practice only, Sita is interested to play tennis. So about that it will be. Okay. So this forget and input alternatively will be active and inactive accordingly your LSTM works. So LSTM will be the solution for your exploding gradient and vanishing gradient which we faced in our RNN. So we can say that LSTM is an expansion of or variation of our RNN. Okay, I hope this much may be sufficient for you. And here a simple calculation alone you must remember always. So whenever you are taking this, the first layer, and at that time computation could be x11 into w. Only that much. But to be uniform, I have to keep the formula as a uniform manner and initializing with some zero padding kind of thing, some dummy value I am giving. So this O0. So this also will be considered. O0 into W dash. This is for the first step, first output, that is O1 is equal to f of so and so. This f is my activation function. I perform this, on that I apply the activation function. Now can you write what is O2? O2 is equal to, Danish friend, can you please write what is O2? O2 is equal to f of x12 into w plus O1 w dash.